So today's rant is about complexity and software. So the thing that I learned from software engineering and dealing with software teams and building software and helping other people build software is that complexity past a certain point can be reduced. There's a certain amount of complexity inherent in everything. Now, this shows up all over the place, not just in software, but it's easier for me to talk about software. It's the thing I know most about. So we're talking about complexity. Probably the best way to understand it is the development of version control. So there's version control, there's rapid application development. Those two things come together. Agile pops out of, the synthesis of those two things, roughly speaking, right? And then the whole world of software just completely wrecks itself. And I'm using this framework narrative. I'm not trying to claim that it's historically accurate, right? I'm just using it sort of symbolically and metaphorically, although it might be perfectly accurate. It depends on a lot of things, like what you're looking at and when, and whether or not you care about timeframes and what connections you see, right? Different industries move at different paces. Some of these things haven't happened in some industries yet, like banking, very slow moving industry. So how does this play out? Well, look, in the old days, I've mentioned this before, 80-20, 80% design, 20% coding. Why? Because the coding's easy once you have a good design. Just is. I've done both, no question about it. Rapid application development, total garbage. Total garbage for quality software. It's fine if you want to do a little project, you want to write some animation, no problem. Some automation rather, no problem. Piece of cake. If you want to do large apps, lots of users, big scaling, any of those things independently, just by themselves, not going to happen. Large teams, not going to happen. More design equals more stability. It equals more security. It equals more scalability. It equals the ability to leverage large teams more effectively and get things done. It also results in much greater quality. Like, you can't have good quality without design except by accident. And if you keep touching it, you'll ruin that. In a well-designed system, you can know what to change ahead of time so that your quality doesn't suffer. Just the facts of life. I could go into that in complexity, but I want to stick to this version control story. So what happens is we get relatively primitive version control systems very early on, 70s or 80s or something, I forget. I don't know all the history at the top of my head. I wasn't there for all of it, not that far back. So you have RCS revision control system, you have VCS version control system, right? Those are sort of the primitive first runs. Then you've got like SVN, becomes very popular. SVN and Mercurial, other version control systems. Why is this a big deal? When you're doing the 80-20 design and you're coding in a nice, excellent, nearly perfect language like C, which has very few actual problems compared to almost every other language ever written, you need to coordinate your code with other people's code. Now, version control is not initially designed to coordinate code. That's not its purpose. Its purpose is so that you don't lose code on computers that are unstable. Because in the old days, even Unix was entirely stable. And people made mistakes. And if you RMRF the wrong directory, everything's gone. that happened. I've seen it happen for years. Like, it happens. I did it once, maybe twice, but I think actually only twice. Thank goodness. These things happen. So version control gives you a way to mitigate some of those problems, especially centralized version control, where it's serving three purposes. Purpose number one is installing a process into your development practice. So sit down, you start to write some code, you've got a design, so you know roughly what you're writing, whether you're working on a module or an API for another group, or just a method or a set of structures or whatever for another group, whatever it is, doesn't matter. Now you can add into that the discipline of checking in your code. And what that means is as you're writing your code, you're going, okay, well, this is going to work like this, blah, 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 blah. And eventually I'm going to compile it and test it against whatever. Usually you write your own test harness. Sometimes you'd have access to everybody's code or an old copy, right? Because you're upgrading version 3, working on version 3 code. Version 3 is not released, so it's 2 point whatever RC or whatever version number. You'd have a copy of that. Everybody else would be working from that copy. You'd all be integrating your changes in, and at the end, boom, you'd have version 3.0. So when your code confidence is high, you can check in the code. Or the better way to do it, which is the opposite of the way we do it now, when your code confidence is high and you've tested the code in a compile and a runtime QA test, which is an integration test technically, then you check in the code because it's right and you want to save the good version. You don't want to save the intermediate bad versions because they're bad. They don't work. So version control nowadays, because it's cheap and easy, doesn't do that, by the way. The other advantage is that version control in the old days was what we called centralized version control. And this is in contrast to something like Git, which is decentralized version control. Now, when you do decentralized version control, you create a problem. So I'm just going to foreshadow that up front. When you're dealing with SVN, RCS, and the old VCS and the old systems, you have the centralized version control, which means if you wipe out your local copy of the code, you lose 1 day's work, most likely, because you check in at the end of the day. Again, it takes the practice of coding and turns it into this nice, repeatable process where you have some stability and you can only slide back down the well so far. You can't delete all the source code. You don't have it all. You can't delete your stuff from that you've been working on for a month because you've been checking it in every day or once a week or whatever. It doesn't really matter. Hopefully you check it in every day. So that's the second thing, is there's a backup copy. Version control gives you a backup copy of your software. So now you've got this process you can put in place, right? You can run it 2 different ways. There's more than 2, but there's 2 basic ways, right? Untested, but high confidence code or tested code goes into the check-in. Now, the third advantage that version control gives you is the ability to roll back your changes. That's really tertiary. I mean, I'm doing these in order for a reason. They are in that order. So back then, in particular, okay, I can go back and look at my previous changes and compare. Nobody did that at first. They didn't need to. Really good engineers almost never need to do that. It happens. You might need to do that 6 months from when you're working, but you're not doing that like in the same week. You know what changes you made. It's not a big deal. Good engineers know this. Not that hard. They're not looking for little persnickety changes and bugs, and that just was rare back then. It's not that it didn't happen, but man, you worked with someone like Richard Stallman. I typed for him once. I got paid for it too, so pretty sure I have the pay stub somewhere. You get an email from somebody about a feature in Emacs that didn't work, or he wanted something changed. I don't remember the exact details. I was just typing. And he read the email and he goes, go to this directory, open this file, and he's talking very fast. I'm trying to type that fast. I was a fast typist. It was a new keyboard, freaking HP, freaking Unix machine with 9 special keys. Not these common keyboard things at all back then. And he kept using the word meta for alt, which just drove me nuts. Left meta and right meta were different because left and right alt keys were mapped differently on his keyboard, probably just to spite me. Anyway, went into the code, had me edit some pound defines in the C source code, save it, compile it, ship it. And, that was very efficient. His development environment was fantastic. Emacs is amazing. I don't use Emacs. Don't use Emacs. Emacs is terrible. Emacs is amazing, right? eLisp is wonderful stuff, right? Shipped out that version right then and there. Boom. That's how good programmers used to be. That's how good a good programmer is. You just tell them, I need this feature. I need this constraint changed. They know what file to go to. They get their development environment set up. 10 key presses, all done, whole thing, changes and everything. I think it was like 10 key presses, all done. I was like, whoa, that's pretty efficient. It's more efficient than my development environment. Mine was pretty efficient at the time, but it was nothing like that. Emacs is amazing. Also, don't run Emacs. Oh, what a nightmare. Oh, eLisp. Oh my goodness. The thing's an operating system. He calls it an editor. It's not an editor. It's an operating system without a kernel. I digress. So those are the three purposes of version control. What happens is, especially with rapid application development, people start to get the idea that, I don't know, we can quickly do mockups, and then we can send that out to the client, and then they can tell us right away if it matches your business process. Yeah, that's great. In the meantime, development's proceeding normally. Like, you're writing code. And the important part about checking in and out your code is you're doing your daily check-ins and checkouts. Nobody else is using your code in general. That's not happening. Sometimes people are pulling the latest code and building it back then, but not very often, actually. And then you get everybody together, or you have a guy. You have that integration guy. I've talked about him before. It's this scuzzy guy in the corner. Doesn't write any code. Fixes everybody else's code or forces them to fix it. Doesn't write any code. Just runs the makefile and makes everything work. He's the integration guy. It's not usually what he was called. Sometimes he's the guy in the corner who worked once a month to do the release. He's a release engineer. That's what he did. That's all he did. He didn't write any code. He wrote all the automation, all the test harnesses, did most of the QA in many shops, right? Did all this stuff. Very versatile person. Could read and understand source code very well. Could check in source code, but almost never did because he just wasn't a day-to-day coder. That's not what he did. He tended to the version control system. He tended to the code integrations, right? Spot problems, right? All that. Very annoyed, very annoying. Didn't like meetings. Wouldn't go to the regular developer meetings. I'm not kidding. Like, this is at lots of companies at the time. And then you're either getting together or that guy's doing the work, or you're all getting together and doing the work of, here are the check-ins for version 3. Let's make sure they all work together and they all function the way we want, right? And so it's an integration process. That final integration process, now you can begin the release process. You've done independent QA testing on the bits of code that you thought were important. Now that you've integrated the code, all the changes from all the developers and all the development teams, however you have it split up for check-ins, doesn't really matter, right? Now all that code's in one place and you can test it all at once. That's true integration testing. Do that final integration test, it passes, anybody, or doesn't, people make changes, whatever. They get everything to integrate, APIs talk together, functions are called in the correct order, structures are manipulated, whatever. Now it's done. Now it can go to the release process. Now all the engineers go and take the rest of the day off. Really, like, they're done. Like, it's been a long week. Let's get the hell out of here. Then the release packaging is done, usually over the weekend, honestly, and release is done. That work of integrating the code has to happen. If you integrate early, you haven't done the final integration. The early integrations may sometimes catch errors. That is true. And if you're really off track, early integration with the current checked-in code can help you know that you're really off track. But when that doesn't work? When your engineers suck. The industry is full of sucky engineers, so they won't even notice this. So we can go to the decentralized version control revolution and the fact that, and this is the power and the curse of Git, you can integrate at any freaking time you want in the process. You can pull everybody's code, and it depends on the Git process. Git is not one tool with one process. You can implement, I think there's at least 12 distinct, different, vastly different ways of integration, of using Git for integration, for version control, for all of that. So one way is called stable master, right? Where unstable changes stay on branches until they're tested and stable, and then you merge them into master or the main branch, whatever you want to call it. Another way is to use branch release, where the main branch is actually unstable all the time. All the new check-ins are going there, And then when it's stable for a half a second, you branch it off, and that's a release. That's actually the way I prefer to do it, by the way. And there are hybrid models available. Those are the two main methods. Either you're merging into the main branch or out of the main branch to facilitate a release. So it doesn't actually matter that much which one you use. There are some considerations. There are some hard stop points, but actually they can both produce the same end result. A lot of this stuff, when I did it, I would just like tell the team, you can do it this way, you can do it this way. And I'd talk about why you want to do it one way or the other. Usually I'd do an analysis on the team and I'd be like, no, you guys should really do it this way because you're not doing it that way now. And that was my job. So, sometimes they listened, sometimes they didn't. And there's tons of branching and merging strategies and hot fix strategies and all these things you have to think about. But if you integrate early and test, it means nothing. No, really, it means nothing. Because the only integration test that matters is the final integration test before the release. The problem with decentralized version control is that it gives you the illusion that you don't need to wait for that. And that there's value in integrating and building early and testing early. But actually there isn't. You're just wasting time. The other thing that happened was, because this is true, right? So because your final integration before release matters, right? And that final integration, the first time you do it, it may not work, right? You're gonna go back, edit the code, do another final integration, right? And oh, Mark, that's not final. Yeah, time works that way. You try stuff, sometimes it doesn't work. You go to fix it, and then the next time you do it, it works. You don't need those versions. They don't need to be numbered. You don't need to understand the change set. Really, you really don't. Like, I'm not saying ever, but it's so infrequent, it's actually a burden. Even if you automate it, it's a total burden on the system. You're using up disk. It's stuff you're never going to look at in 99.99999% of the cases. You'll never need it. If you do need it, it's too much information. So the amount of time it takes you to search that information versus the amount of time it would take you to just troubleshoot it correctly and fix it is asymptotic. In other words, the amount of time to fix it is less than the amount of time to search what changed. Sorry, just mathematically true in almost every case. And there are a few exceptions, but they're not worth it because the vast majority of the time it's quicker to just figure out what's wrong with the code and fix it. And there's other value to doing that. Like, now you know the code. Like, you should always be able to do this. You should always, as a software engineer, be able to do this. If you can't do this, you're not a good software engineer. I'm sorry, you're just not. And that might be okay. Like, you don't have to be a super good software engineer. Mediocre software engineers, junior software engineers are all required. But like, I can always do this with my code. You can just tell me what's broken with my code, and I can tell you approximately where the bug is. I will just know. Sorry, I have a good memory. I know how this code works. I wrote it, right? Can't do it with other people's code. Oh, actually, that's not true. Usually I can. That's a different story. Sometimes I can't. Aspect-oriented programming is such a mess, especially with decorators. I can't even find call stacks and that stuff. It is decorators just screw up your call stacks. Can't debug without call stacks. Because you are chasing an unknown quantity in the future, i.e. final integration or your release integration, however you want to put it, right? Your final release. You can fool yourself into thinking if you get closer, right? If you just step closer to that release time, to that final integration time, that you won't have bugs in production is wrong and backwards. You shouldn't be testing before that final period. And one of the advantages to doing it that way is that you find good and bad engineers really quickly. And it's good to know the better engineers from the engineers that need more help. Okay? By hiding your bad engineers, you're hiding your ability and the group's ability to make them better engineers. In other words, you're screwing yourself. You're screwing yourself. You need to know who the good engineers are and who the bad engineers are so you can have a good balance on your software team and make better software. That's what makes better software. 30 years, that's what makes better software. You know what doesn't make better software? Anything else. You know what you don't need for better software? Version control at all. To this day, I don't even like version control. I'm a version control expert, literally. Actually, paid hundreds of dollars an hour to do version control for people. I hate version control with a passion. Hate it. I do use it occasionally. Most of the time, I don't. On my projects, don't need it, don't use it. I make hard copies, like with the CP command, and boom, that's it. I've got backup copies. I'm very careful about my changes. Most of my projects are really small. To be fair, like I'm not working on big stuff. I'm not trying to boil the ocean, right? I got small stuff. You know what else doesn't make better software engineers? More integrations. That makes worse software engineers. You know why? They're not coding. They're not finding their mistakes where they matter and correcting them. They're busy writing unit tests. Unit tests are a big deal. Unit tests were designed in the day for the problem in C++ of private functions. Somebody would write a private function. They would say, I wrote a private function, just call my function. It should give you the right data. When it didn't give you the right data and you didn't have access to source code because source code control was different or non-existent back in the 80s, 90s, and that engineer who wrote that private function screwed up, right? And that's why you force the discipline. It's a process now. It's not about smart. It's about process, making people better, which I agree with. Write the unit tests. Show me the unit test results. Now I know if your private function works. Now I don't have to go through the hassle. I had a buddy who worked a month on a project. Whole time the guy who wrote the private function had a bug. Whole time. He wasted a month of development time. He was pissed. Excellent engineer. Oh my God. Oh my goodness. Could read hex off the screen. I was like, huh? And I could do that like for 2 months of my life maybe. And that was it. I could not. I mean, he could actually read object code and stuff like right out of the object files. I could never do that. I can kind of read some of it maybe, but like no, he was good. He was really good. Very smart guy. A month of his time wasted. He kept thinking it was his bug. That's what unit tests are for, to enforce discipline on the software team when they can't see each other's code and validate it. What you see with the rise of Git is code reviews. What's a code review? Distributed cognition. It's two people or more looking at the same piece of code to make sure it does what they think it does. Okay, if you're doing that, you don't need unit tests, guy. You don't need them. Sorry. Am I saying don't ever write unit tests ever? Yes, actually I am. Unit tests are a waste of time. Unit tests are 4 times more code than the code you're writing. What are you doing? That means 4/5 of your coding time is in code that's never going to run in production, that you don't need or care about. You can replace that with a code review, okay? And now you're writing more good code more often. Seems like a win. Sorry. There are probably exceptions that I would be like, yeah, okay, do some unit tests here. But I don't think so. I think all of your testing should be done late cycle. I have a lot of evidence for this. First of all, I've done this for 30 years. I've seen the results. Early cycle testing, unit testing, anything below integration testing is total waste of time. Total waste of time. Does not improve software quality, does not improve speed of development. I mean, it just makes everything worse. It's just a time wasting, time sucking, terrible idea. Don't do it. No reason to. Now, integration testing. When you find that, oh, we should have done unit testing, you now know the engineers that need help. Go fix that problem. Make them better. They'll make your company better. They'll make your project better. Your project will get better. I like better. Better is better. When it comes to integration testing, you should integration test from a deployment, which is not a release, from a deployment in modern times, because now we always had development, QA, staging, production. Staging is optional. Sometimes you have staging and performance. Again, optional. I've only met one case where it wasn't development, QA, production at the very least. That was a very special case. And then I was like, yeah, you guys just need development and production environment. That's all they needed. They didn't need a proper QA environment. And that's because they were doing development on their laptops and they were writing very high level code. There were no build times. It's all interpreted Python code anyway, Python and R. So Python, R, and Tableau to be exact. In that environment, they just kind of test it on their laptop, and then the next thing you need to do is spin it up into your quote development environment, which can double as your QA environment. You really did the development on your laptop. Now you have a common development environment. Somebody else checks it, right? So you could call that QA if you wanted. Somebody else checks it, and then they say it's good to release, or they release it, right? So now you write it, somebody else looks at it and releases it for you. Great scheme. You don't need version control for that, by the way. Not saying don't use version control. Version control can help with that process. There's a lot of value in slowing down your software engineering practice with check-ins. It's a very valuable thing, just process-wise. Normally, you have at least these three environments: this dev, this QA, and this production. Do a development deployment. Do as many as you want, although again, I think they're a waste of time, right? Try to get things that fit together to be checked in on the same schedule. If you can't do that, I would argue there's something wrong with either your software team or your planning. And it's probably, the thing that's wrong is probably lack of design, but there are other possibilities. So I don't want to be hardline on that, even though I'm a software architect, among other things. So I'm big on design. Like, design's really important. It's the most important thing for quality software that's scalable and doesn't have a lot of bugs and is fast for your users and secure. You're not going to get that any other way. Design is the only way to get it, or the only way to get it and keep it. So for me, if you do a deployment, which is an integration, because you're deploying a package, a runnable version of your software. It may not be fully ready for production runnable, but it's at least runnable at the code level. And that's fair for developers to do this. I don't think you should do it every day, maybe once a week. This is velocity questions. I believe in slower velocity software, right? Then they can test the core of their code and make sure it works the way they expect, because the next layer of integration testing that goes into the QA environment is all about whether or not they're handling the environment correctly. Because the way you point at things in dev has to be different from the way you point at them in QA, which has to be different than the way you point at them in production. Those things are wrapped up in your security because you can grab data from the wrong place. If you grab production data from the development environment, that's dangerous. You can cause problems. Don't ever let your software engineers do that. Good DevOps practices put up those cages. People will tell you the opposite. They're wrong. They're just wrong. Sorry. Seen it too many times. I've watched companies go from well-gated to ungated. Disaster every time. Every single time. I'm not saying that they noticed or that they cared or that they switched back, although almost all of them did after I said, yeah, this was dumb. But it's always a disaster. Unequivocally. And we know why mathematically that's going to happen, but I don't want to get into the math. So having those gates set up tells you software is secure, software is able to point at different environments, which is really important because software engineers often take shortcuts, they hard code things, and then they forget. And so the QA integration testing is really important to find those bugs. Those bugs are not going to not happen, and they're not going to be able to be seen by normal integration testing. They're not going to be caught in development. That's not going to happen. I actually had a development team once who was dead set. They had a development environment, one machine in your development environment. That's all you needed, right? You're not running huge amounts of data. You're just developing the code to make sure the root code kind of works. QA environment had 2 servers and therefore had a load balancer. Production, obviously, more than 2 servers, load balancer. So they decided, because they had load balancer bug in their code, that it just didn't play well with the load balancer because they were mishandling host names. Oh, such a problem. They decided to put a load balancer in the development environment to catch that bug early. Guess what doesn't work? A load balancer on a single machine is not going to catch a hostname bug ever. It's never going to see it because it's never going to exist there. I told them this. I warned them. They ran into the bug. And I said, I told you that I fought them the whole way. And I said, I told you that doing this was dumb. I told you that doing this was going to piss off the IT team, which it did, because they knew it was dumb. And it didn't solve your problem. You just can't get in front of production. You can't say, we're going to drag production into what we're doing today and find all the bugs before it gets to production. That's never going to work, ever. Production release is a future event, and it can be imperfect. Now, if you use the system that I know works, that I didn't develop, was already in the industry long before I was in the industry, where you have an integration test in QA and you actually test it that way, and that also teases out the environment and the security bugs, because it will do both, then the likelihood that you're going to run into a problem in production is lessened. There are only 3 types of bugs that you can have in a production environment. Those bugs are hard code bugs that didn't get checked for whatever reason or didn't get caught. That'll happen. It's unavoidable. There are unintended side effects to everything. I don't care what programming language you're using. It doesn't matter. It's going to happen. There are infrastructure bugs where there's something about the production environment that is slightly different, like load balancer or host names or the setup of the system, because you made a setup change in your development environment and maybe it got made in the QA environment because the QA guy knew about it, but it wasn't in a release instruction, so it never made it to production environment. That happens, right? And data problems. Those are the only 3 places you can even have bugs at all in software in a production environment. I mean, it'll happen in the QA environment too, but let's just go with the big case. If when you see an error, you don't know which through 3 buckets it's in, that's a problem. You need to work with a systems guy or a security person, because it could be a security-based bug, to figure out, is this an environment problem? Is it a systems problem, a setup and infrastructure problem? Is it a problem with the data, or is it an actual problem with the code? You need to know that. When you try to squish the complexity down so that you're integrating early into what you think of is as close to the production release as possible. So you're compressing time and you're compressing the coding steps necessary to test infrastructure. What you're doing is moving the complexity. Okay? The complexity is going from this simple, well-staged environment into complexity at build time, complexity and automation of deployment, complexity and automation of release. And you haven't done anything about the bugs, except increase the likelihood that you're going to have a bug in production. Ironically. Why? Because you can't catch production. It's in the future. So all of these attempts come to naught. And you may say, well, Mark, what's the point of all this? Let's add containers into the mix. Containers are meant to solve particular problems. However, one of the problems that containers masks is works on my machine. Have you heard the works on my machine meme? To this day, this happens. I don't know why. I don't know what's wrong with developers. They just can't configure computers correctly. Developers usually end up loading lots of stuff on their machines and forgetting what they loaded. And then there's something in the path on their particular development box or in their particular development VM that isn't actually on any of the other machines, including of the other developers. These bugs tend to get caught last. When you're dealing with containers, developers tend to be making smaller code changes and packaging them up as full pieces of release code. Calling them APIs, which they're not, by the way, all you've actually done is carved up what should be a nice, fast, scalable, monolithic piece of software, and there are exceptions to that. not saying don't use service-based architecture. You should always use service-based architecture. But microservices, it has its uses, but they're rare. And, if you don't know that, you shouldn't be using them. When you package up microservices, especially in containers to get them to work, you now have a bunch of differently configured containers. They may or may not have security bugs. This is why we have cybersecurity all of a sudden. Never had cybersecurity before. It wasn't even a thing. Nobody even thought about it. Why? Security was built into the design of the software. Software was monolithic. Software had gated release from development to QA to staging to production. Guess what? You never see security bugs. Why? Because they never make it out of QA. You test for all your security in QA, and because it went from development to QA, the security is right. You can test it again in staging, you test it again in production. You never had a security bug in production. Ever. We never had that. It never happened. Ever. We just tested for it up front. No breaches. Because you've changed when things get integrated, and now the first time that the running code that the user sees is integrated by containers in the production environment, all the bugs that you would catch in QA get caught in production instead. That's not better. Including the scaling bugs, which you would catch in something like a staging or a performance environment, right? That's not better. Usually your staging environment, by the way, would catch. And people use it different ways. Sometimes I would use staging for performance. Sometimes I had a special performance environment for various reasons. Depends on the software. It's not a hard and fast rule. Sometimes you want two, sometimes you only need one. Really depends on the process flow and a bunch of other things. Determination to be made by team, right? Custom for the team. And when you have that performance environment, you can test your scaling. That's what it's for. When you have the staging environment, you can test for data errors. Staging environment is where you take production code, production data, match it with the ready production code, and test. That's what staging is for, usually. You can do clever tricks like not copy your production data and make it read-only, or only allow the staging to modify certain production data that is never used by customers. That's another way to handle it. There's lots of ways to handle these things, by the way. Look, pay me a few $100 an hour. I'll tell you how to do it all. Custom for your system. I'll do analysis. The whole works. Really, really important. Really important. You can't do that with containers. You could maybe automate a way to do that correctly with containers. I'd have to think about it. But because containers are done by the developers, you've removed the experts in systems engineering and security from the equation. You now have to insert new cybersecurity people to do like testing of your infrastructure and pen testing and all this crazy stuff that we never had to do more than once. Maybe people would do it once a month just for auditing purposes, whatever. Never happened. It was not needed. When you design first, security isn't a concern anymore. It gets built into the design. Software engineers get constrained. They get pissed off. They have to do things a certain way. They don't like that. That's too bad. It's secure. Their way is never secure. Ever. Ever. What is expedient and seems clever and efficient to the software engineer is never secure, ever. There are mathematical reasons why this has to be true. I'm not going to get into the math. That's a problem. So now you've taken your, what used to be compile first, deploy, test, release cycle, and you've moved that complexity, that inevitable complexity of having software running in a production infrastructure on production data with production code to the end. That complexity that you moved from the development environment didn't go away. You put a bunch of garbage in the middle that isn't making your system better, but is making it worse. It's guaranteeing more bugs in production, for sure. Mathematically certain, guaranteeing bugs in production. It's crazy. All you've done is move the complexity to a place where you can't fix the problem. You need to keep the complexity early in the process. You need to keep it close to the developers because they're the ones that are best qualified to fix these things, right? Some of the problems will be infrastructure problems. That's why you need DevOps people. You need infrastructure engineers. I'm also an infrastructure engineer, incidentally, what I've done most of my work on. You need those people to do their job, to know their stuff like systems and how to set things up. And if you're going to have containers, let your systems guys do it. Don't let your engineers do it. They'll make the containers insecure. Then you'll have to do something crazy to secure them. Now you're losing performance and scalability and creating all kinds of problems and expense in the cloud and everything else. It's inevitable. That's what I mean by moving complexity. The job of integration should be done in the development environment by the developers. Those other bugs, which will show up in a properly gated and set up QA environment, there's no better way to do that. If you try to remove that gate, you push those more bugs into production. The number of bugs is not going down. That's not happening. There's no way you can get close enough to production to reduce the bugs. All you do is put more bugs into production. So that's what I mean by moving the complexity. With containers, you're just creating a lot of complexity, creating a lot of developer machines, all configured differently, by the way. That's what containers allow you to do. And you can say, oh, Mark, we template our container. Yeah, show me a development environment that has one template for containers. Or better yet, which is the way systems engineers do it, one template for application tier. So UI components go on one tier, your mid-tier components, your web servers go on another tier, right? Your next down mid-tier, because you can have two mid-tier components. It's a very complicated system. They have a different system config, right? And then your backends, right? They have different system configs. Maybe you have multiple backends, right? That's fine too, right? Those are systems images. They shouldn't be touched by software engineers ever because software engineers don't know anything about systems work. Zero. They don't understand networks. They're not supposed to. They should focus on code. Coding's hard enough. You don't need to know all this other stuff. That's why you have systems engineers. When you try to compress that and make the software engineers do all the work, you get a mess. You get an unintegratable mess. They will always make new containers or make changes to containers that affect other people that they don't understand. Or then they'll go, you know what, that affects my container, make your own. You're never going to end up with a nice clean system the way you would if you had the systems engineers bringing down the hammer and working with the software engineers to say, no. You only need 4 different images. Fit it into one of those 4 things so that it's secure and scalable. Because that's how it works. The software engineers can't make it secure and scalable. They don't know how. And even if they did, they wouldn't do the work. It gets in the way of their release time. This is why Agile is dangerous. Agile focuses on release time. Release time is the worst measure in software. I don't care how often you release. I care how painful your release is and how careful you are with the release, because that's what makes quality secure software. You know what else makes quality secure software? Nothing. There is no other way to do it. No other way. Keep your complexity where it belongs. The total complexity is not going down. By trying to move the complexity out to the production environment, all you're actually doing is moving the bugs there first. In the meantime, you're creating a bunch of non-coding things for your developers to do, and I don't think that's better. But I do know that it's worse. So that's complexity. You can't get rid of the complexity of having to integrate your software so that it's ready for your users to use in a quality and secure fashion. You can't reduce that. You can move it around, but it's best in one place and it's not best in the other. Beware containers. Beware distributed version control. Beware frequent check-ins and frequent builds. You shouldn't need that. Beware not knowing who your good and bad engineers are. Like, you are not helping people by not knowing who your bad engineers are who need help. You're making everything worse. Complexity and where it goes matters.